Okay. Um, Previously, we give a very quick introduction to the general phase transformation in the solid. From this class, we are going to focus on a particular type of solid state phase transformation, which is called precipitation. And the first, let's look at the initial stage of the precipitation um, phase transformation, which is the nucleation process in precipitation. Okay, that's the focus for this lecture. Precipitation, as we mentioned, is solid transformation due to the change in solubility, typically with respect to temperature. You experience precipitation quite often as you cool the material from high temperature due to low temperature, and as a result, quite often, with decrease in temperature, there's a reduction in solubility, or the solubility decreases in the matrix phase. Okay? And this precipitation phenomenon is quite often very useful for strengthening of alloys such as aluminum alloys or titanium alloys. And we'll talk about more examples as we proceed. But generally, for precipitation process to happen, for this phase transformation to happen, there are two possible mechanisms or two different pathways. One of them is called nucleation and growth pathways. In this process, it often involves a defined interface. A defined interface between the two phases, the new precipitate phase and the matrix or the host material. This interface arises due to quite often change in lattice parameter and composition, or even the crystal structure between the new phase and the matrix phase. Okay. Uh, in order for the precipitation to happen while nucleation grows, we often need thermal activation. We need to the heat process in order for the process to overcome a barrier. A The barrier quite often comes from the defined interface between the new phase and the matrix phase. This added interface and associated interfacial energy is a barrier, and to overcome the barrier, you need thermal activation. You need to wait for um, run for occasionally the kinetic energy is high enough to overcome the barrier. Okay. And in order for this nucleation and growth process to happen, the local nuclear size has to reach certain critical size, which we will talk about in a moment. If the new local cluster size is smaller than this critical nuclear size, even the local region is arranged as the new phase, it may like solidification process. The cluster with new structure may arrange back to the host or the matrix phase. It is only after the local cluster size reaches the critical size that the growth from that point becomes spontaneous, become a downhill process. And as we mentioned, the defined interface between the new phase and the matrix may come from difference in lattice parameter. For example, as people observed between the system of copper and silver, both of them have the same um, FCC crystal structure, but the precipitation occurs due to the very different lattice parameter. It may also happen due to the different crystal structure, which, for example, people see in the um, alpha ion to alpha ion plus cementide phase transformation. Okay. The other mechanism or the other route in order for precipitation phase transformation to happen is through the so-called spinodal decomposition. This is a compared with nucleation growth, spinodal decomposition is relatively rare, which means less common. And for this spinodal decomposition, there is no defined interface, which means at the beginning stage of the precipitation when the new phase form, there's no distinct difference between the two phases, the new precipitate and the host. It's hard to pinpoint where that interface location is. It seems to be much more gradual in terms of lattice parameter, in terms of composition, and the crystal structure it will always be the same between the precipitate and the host. In order for this process to happen, we just need composition fluctuation, and we'll talk about there is no need for thermal activation because it's always a downhill process. There's not much a barrier involved. Okay, and there's no big nucleation because there's no defined interface. So at the very beginning of stage, it's hard to pinpoint what's the nucleus, what's the matrix. There's no nucleation process. Okay, we'll talk about these two different mechanisms in greater detail. For this part of lecture, we'll focus on the nucleation and growth process, the first mechanism or the first pathway, while the spinodal decomposition will be the second pathway that we'll focus on later.